So we've looked at activators being ortho-para-directors and deactivators being meta-directors, but there is an exception to that rule, and that is when we have a halogen attached to the aromatic ring. We discussed how they are deactivators because they withdraw electrons via induction, but it turns out when we run the experiment with an electrophile plus bromobenzene, we find that bromobenzene is actually an ortho-para director. So let's look at that a little more carefully. And in this case, I will use a generic chloride as my electrophile. And I'm going to put the chloride on the para position. And here I have a resonance structure with the cation adjacent to the bromine. Remember that halogens have 3 lone pairs, so they could, in theory, donate those lone pairs, and we would get this resonance pattern. And of course, there's one more. And so again, we have this extra 4th resonance structure that we saw with the activators when they added ortho or para. And so by adding the chlorine to the para position, of course we could also have added it to the ortho position. They would get us to the same 4 sets of resonance structures. We achieve this extra 4th resonance structure. Now, of course, I hope that you're a little uncomfortable with a halogen with 2 bonds and a cation to it. That's pretty unusual. Of course, halogens are very electronegative. They do not like to be positively charged. So yeah, this is unusual, and that's why they're still a deactivator, right? So this resonance structure isn't necessarily helping us speed up the rate of the reaction. It's just giving us support for adding the chloride or the electrophile either in the para position or the ortho position. We get 4 resonance patterns in those cases. If we added to the meta position, we would only get 3. So this is the interesting outcome here. Even though a bromine substituent makes the electrophilic aromatic substitution reaction happen slower, it is still an ortho-para director because we get this 4th resonance pattern. So the take-home message here is that induction leads to deactivation, and that induction is winning over this resonance in terms of the rate of the reaction. Even though we have extra resonance, induction is still playing the major role in determining the rate. And again, the induction is pulling electrons out of the ring as opposed to pushing them into the ring via this extra resonance pattern. So induction wins over resonance. And again, the only way we know this is by running this experiment and observing the outcome. We can observe the rates and find out that it's a deactivator. We can observe the regiochemical outcome of the reaction and find that our electrophile prefers to add to the para or the ortho positions. And so then we can come up with this resonance here and this mechanism to rationalize the outcome in terms of the ortho-para regiochemistry.